Welcome to a meetup. We'll start with the introductions. As has already been said, my name is Katharina Dankert. I'm in Berlin at the moment. I'm an infrastructure developer with Thoughtworks, and I've been at Thoughtworks for about 2 years now. My background is actually quite colorful. I studied medicine at some point in time, but for the scope of this topic, I have a systems engineering background. And during my daily work, I mainly think about complex infrastructure systems and how to secure them. So when it comes to security, what I find extremely interesting and what I'm always learning more about and dabbling with is network forensics, as well as binary reverse engineering. Yeah, to the topic of Agile Threat Modeling, I actually came during my work at Thoughtworks, because I gathered more and more insights in what is actually needed in terms of prerequisites to be able to create and deliver secure and sustainable software and systems. And with that, I hand over to Jennifer.
Thank you, Katharina. Hello, my name is Jennifer Parak. I'm a software developer at Thoughtworks, and I've been at Thoughtworks for over a year now. I discovered my passion actually a long time ago when I was still at university during one of my computer security modules. And I eventually went on to write my master thesis on developing a convolutional neural network for cracking visual captures. When I moved on to the real world of software development, I was usually part of a dev team that wasn't really concerned with security. So it's usually the work for DevOps or a security team. And now as a developer at Thoughtworks, I actually started to engage a lot more with security again, since we put an emphasis on integrating security as part of our development cycle. And Michael, would you like to introduce yourself?
Yeah, hello, I hope you can hear me. My name is Michael. Like Katharina, I work for Thoughtworks as an infrastructure consultant. And my journey into security started at a small web agency where security was basically in the hands of two knowledgeable sysadmins. And the software development teams mostly relied on their judgment. My second job then was in a large enterprise where we had the famous security team in our department. And security was mainly going through long lists of security controls, either before a project started or once it was close to go live. And with Thoughtworks, I came in touch with a more agile approach to software security, and that is what we want to talk about for the next 90 minutes. So now that you know a little bit more about us, we would maybe like to know a little bit more about you. So feel free to add some notes in the chat about your background in security. So yeah. So what are we going to talk about today? The first point on our agenda will be a motivation on why Agile Threat Modeling is a good approach to tackle security in Agile software development teams. We then have a theoretical part that will introduce some tools and challenges around Agile Threat Modeling. And we also want to share some tips and tricks with you. Then we have a longer practical part where we'll conduct an actual Agile Threat Modeling session using a fictitious example. Unfortunately, due to almost around 80 people in the group, we cannot make this hands-on for everyone, but we hope to give you a good impression on how such a workshop looks like. In the summary, we have the chance to reflect on what we learned and saw, and we will also provide an outlook on further topics related to security. We will have question blocks between each block, so you can always put your questions in the chat and we will answer them like every 10 minutes. So little patience, but feel free to post questions. So what motivated us to do this meetup and why are we so passionate about talking about Agile Threat Modeling? So as you will see in the next slide, the number and the extent of security incidents drastically increased over the past couple of years. So since companies are more and more shifting towards digital products, they also become more vulnerable in terms of security attacks. And we saw in the past years that Agile software development approaches proved to be a good choice for today's quickly changing world. And so we think that it's also time to rethink our take on security. So we start with pointing out some shortcomings of current security approaches, mainly when they come together with agile software development. And we think it's also time to rethink how security should be handled by agile software development teams. So this meetup will finally introduce a tool called Agile Threat Modeling that's been used a lot at Thoughtworks and works well for our approach on agile software development. And now I hand over to Jennifer.
Thank you. So let's talk about security. On this slide, we see security incidents of companies aggregated by the number of records that were lost. And it really shows us several things. So we see security incidents can happen all the time. We also see many big and well-known companies in this graph. And it really tells us that it's not a question if, but when someone tries to hack us. The problem we mainly see is that security is often an afterthought, especially when the deadline is looming. And with cybersecurity risk increasing, software development teams need to be more effective in building security into their software. Can you go to the next slide, please? So how can we do this in an agile software development setup? Back in the days, and when we're still working in a traditional waterfall software development setup, we would have a team that does the analysis, then a team that does development, a team that does the testing, and then we hand over to operations. But now that the software world has moved to a more agile way of software development, we actually focus on implementing a more iterative and collaborative approach. So we have self-organizing and cross-functional teams, and that helps us, or that helps the team to do the analysis, the development, and the testing, and ideally also the operations within the team. So eventually our goals are to be responsive to change and to deliver value as fast as possible. And we know that only software that runs in production can actually generate value. So what we do to achieve this is we ship software in small increments quickly, and that requires us to think about security during development of these small increments. I will now hand over to Katarina, who can tell us more about the challenges we face during traditional security approaches.
Yeah, thank you. So let's start with having a look at what this current status quo for threat modeling in particular is in the traditional enterprise security setup that we still see a lot and is probably not going to go away for the foreseeable future. And sometimes with good reason is not going to go away for the foreseeable future. So I don't want to create the impression that this process and the current way of doing things wasn't originally created with good intentions or with good reason. We're going to talk about this a little bit later as well. But what is the status quo? And I'm sure like what the traditional way of doing security in especially large enterprises is something that a lot of you are familiar with from your daily life. But what this means is, and Jennifer has already said that, we usually have a team or a department, depending on the size of the company, that quote unquote takes care of security. And when it comes to threat modeling, that usually means that a threat model document is created by this team. And I know that I've already seen comments in chat saying, I'm looking forward to talking about Excel sheets because the documents created in this are usually quite unwieldy. They tend to be hard to distribute. They're usually not known for their ease of being filled out. So there's a lot of challenges with the documents itself. But the process of, or this kind of threat modeling has other challenges as well. And that is more about when it is done. And from in the traditional way of doing threat modeling, we usually speak about the security sandwich, right? Before a project starts, during the project requirement or inception phase, security is done by filling out the threat model, taking what is at that point known about what the project plans to do. So this is our bottom slice of bread in a security sandwich, and then development happens. And at the end, before the project goes live, usually we have the second slice of bread of our sandwich, where again, the threat model is filled out and it is checked whether the initial plan still has something to do with reality, which I probably won't surprise you to say is usually not the case. But to be more specific, what are the actual problems that we see? So the feedback loop is super long, right? If I have a relatively long software development project, and usually a complete product development takes a little bit of time, I will have a significant amount of time between my first threat model and the second threat model. The second problem we have is there's no way to react in between. The state of our software changes as we develop, but in this traditional model, the threat model doesn't. And then an additional problem is that the whole process tends to leave the team that is developing the software feel quite disempowered, because there are people coming in to do security, and they are seen usually as an external disturbance, because the development team has hands-on experience with the software for a significant amount of time, and then suddenly someone else comes and in a way questions the team's actual expertise and asks questions about the system that from a team's perspective, they don't know anything about. So the team can feel that their knowledge about the system is not actually valued. One thing in particular that I want to point out at this point in time that always gets me, especially about the external view, beyond the feedback loop and the time, is that what this also does, it reinforces a notion that security and secure software and system design is this arcane area of knowledge that can only be understood by a small subset of people. When in actuality, a very reasonable level of security can be gained by just applying good engineering practices. And a lot of the security issues we see are not the super interesting exploitation of some side channel attack to invalidate areas in memory, but actually that the permission concept of the database didn't go beyond has root user, right? Or database isn't encrypted. And so if you only take one thing away from this meetup from my side, then let it be that software and system developers actually already bring enough security expertise to their own products to tackle a very, very useful baseline of security issues. And now I hand over to Jennifer again. No, sorry, Michael.
Yeah, thank you. So maybe you have already stumbled upon the principle of shift left on security and wondered what this means. So what shift left actually means is that we want to put security at the very beginning, or in order from left to right to the very left of our software development lifecycle, and therefore shift left. It certainly does not mean that we want to sacrifice security for the sake of faster delivery of software. I hope the following slide will make things a little clearer. So this slide depicts a prototypical software delivery lifecycle, or as we often call it, a path to production. So we start on the left with some requirements analysis and maybe some architectural decisions. Then work gets split up in user stories, which are implemented by one or more development teams. And at some point, software finally makes it into production on the very right side of this diagram. In Agile software development, the path to production is a loop that repeats itself over and over again. So more or less for each small increment of software that we build. Now, shifting security to the left helps us to avoid the shortcomings of the security sandwich that Katharina just explained to us, where security is often treated as one last thing to be done on the very right side before we can go live. Another definition of shift left on security is to build security into the software delivery process instead of making it a separate phase that happens downstream of the development process. So the goal is to get the whole software development team involved in the process and we don't want to leave it to some security experts anymore. You might now wonder whether all this is just a gut feeling of some thought workers, or whether there is a correlation between how software development teams treat security and their actual delivery performance. So for those of you who are not familiar with the book Accelerate that is shown here on the slide, it is based on a survey called the State of DevOps Report and uses statistical methods to analyze the performance of software delivery teams and correlates them to their approaches and capabilities. And we can see in this book that with respect to security, when a team shifts left on information security, that this very positively impacts their ability to practice continuous delivery. And this in turn positively impacts delivery performance. So with this in mind, let's take a step back, and Jennifer introduces the idea of threat modeling in the next slide.
So what is threat modeling? For us, it is a framework that we use for thinking about risk in a well-defined scope. It's based on identifying threats in order to develop mitigations to them. So our goals that we have at this stage are, we want to evaluate our potential cybersecurity losses in our system. We prioritize the severity of these potential threats, and we mitigate the threats based on their impact. Now, before we jump into what Agile Threat Modeling is, I would stop here for questions. Jenna, Katarina, are there any questions that you came across?
There are no questions yet, but feel free to just ping one to the chat at this point. So wait a short bit, and if not, we can move on, and maybe you can also answer questions to this part later on. It was just to make it a little bit more, to flow a little bit nicer. Okay. Okay, then I would suggest to just go on. Perfect.
Excellent. All right, then let's have a closer look at our path to production that Michael already briefly introduced when we talked about what it means to shift security left. And as you can see in this, we have actually made this path to production a loop, as we would expect to see it in a project that actually uses an iterative approach to software delivery. And the loop that we show here is actually not entirely true. We would expect to see many more loops in a path to production. For example, if one of our pipelines or one of our tests fails, then we'll probably have to go back and have a look at the code we wrote. So that would be a smaller, more implicit loop in the path to production. The exact details of your path to production, if you map it out, will probably look different than this. But there are some meta patterns that can usually be applied to all paths to production because they are inherently attached to developing software. I briefly want to go over the phases that we see. And so we start with gathering requirements on the very left and doing analysis of them before we actually write the code that we need to put the requirements or the feature that we want to ship into software. Then we will have some kind of testing phase, depending on how we test. This will be very close to the code or in our deployment phase. Then we will get feedback from our customers after it is deployed. And then we will, again, feedback into using this, or we will loop this back into using this feedback to get new requirements for our product. Now, one of the things that I want to say, that even teams that work in an agile way tend to integrate security as something of an afterthought. And even if they have an agile way of writing software, and if it's like a loop in the path to production, it can still be that even agile teams see security as something as this last resort kind of thing that again comes in from the outside and needs to be done. And I think the reasons for that is, one of them I already hinted at, that security is still seen as this arcane area of knowledge. And then the other reason is that I think it is sometimes hard to talk about security issues, or we sometimes experience it as hard to talk about security issues with business people, because sometimes we have a challenge in saying, why should we spend this time, right? Like, making this that much more secure will take this amount of time. That is usually something we can say, but why should anyone care tends to be harder. Even though on like this meta level, in the perfect world, everyone thinks, oh yeah, security is super important. If we go down to it, in real life, we tend to see problems there. If we could go to the next slide. So let's zoom in a little bit more before we go forward. And I just want to say that what we will look at today, as you can see, is the maximum left shift of security in our path to production. And this, in our opinion, is Agile Threat Modeling, thus this meetup. As you can see, though, in this slide, all the other parts of our path to production have their own opportunities for security controls. Some of them are rather low-hanging and easy to implement. Some of them are not so low-hanging. But just as a teaser, I want to say that we will come back to this before the end of the meetup briefly and talk a little bit more about the other parts of the path to production as well. And now let's actually get started with the theory of Agile Threat Modeling. And to actually be able to do Agile Threat Modeling, we need to know what we protect. We need to know what our security goals are. We need to decide how we tackle them, and we need to know if we were successful in tackling them. So Jennifer and Michael will shortly talk about all of these points in more detail and explain what they actually mean. But one of the things that I just want to point out briefly is that even though we will talk about what assets are and how to do it, and we'll introduce how to create what is called an asset library, this will not actually be part of the practical example today. So we won't actually create an asset library today. We will work under the assumption that we already know what our assets are. But with the framing of our Agile Threat Modeling, from figuring out what we're trying to protect to checking whether we were successful, what we want to do is answer 4 key questions. What are we working on? What can go wrong? What are we going to do about it? And did we do a good job? And now let's have one more look at a little bit of theory. I want to briefly come back to the dichotomy, or possible dichotomy, between having a threat model, so the traditional security sandwich approach, and Agile Threat Modeling. And as you can see from the slide, I don't actually think that this needs to be mutually exclusive. There is the obvious reason, because even in continuous threat modeling, you'll produce some kind of documentation. At the very least, if you generate a ticket that deals with the threat you've identified, that will be in your ticket management system. You will probably have some kind of way to collect that, which we'll come back to, or you will have some kind of some way of documenting your decision making overall. But I think there's even in an organization where you are still working with the traditional security team, and the security team is doing the sandwich way of threat modeling, I think that shouldn't stop you from doing continuous threat modeling either. Because you can, in a way, you can use the continuous threat modeling to pay security forward, if we see it from a traditional perspective. And again, we devs, security, and business people do try to solve the same problems, in my opinion, if we listen to one another. So my heartfelt opinion is that we should really try to use Agile threat modeling not only as a way of improving our software, but also as a way to engage with the security team, for example. Come into a discussion where we see, yes, we're actually trying to solve the same problem here, and thus also have a chance to impact culture, which is probably a very, very Thoughtworks way of seeing it. All right, let's have a look at what assets are.
Yes, let's do that. So Katerina already told us, like we want to start with knowing our assets. And this is really important for us to frame our discussions for a threat modeling session. So we want to know what we want to protect and at which priority. Assets generally are valuable goods in our system. They have value for our organization, but also for the attacker. So this is why they offer an attack surface. So when we identified our assets, we want to think about them in terms of our business goal. An example I can give, one of our assets could be user data that we store in a database. And now if we put this in perspective of a business goal, actually what we want to do is protect our customers' PII, which is the personal identifiable information, because if we fail to do so, that would actually have drastic legal consequences. And now can you move to, thank you, next slide. So assets are tied to security goals, which we derive from our business objectives. We use something called the CIA triad. It stands for confidentiality, integrity, availability, and this is a model that we use to define security goals for every asset that we've identified. And then once we've reached a point where we defined our security goals, from that we derive our disaster scenarios. I will, in the next slide, I will present a very concrete example, but just bear with me for a minute. So our disaster scenario actually means we define what could be the worst thing that happens in terms of each element in the CIA triad, and then we rate its impact. And just to summarize, what we're actually doing at this stage is we want to align our the concerns of our key stakeholders with the business objectives. And we want to create a shade of understanding of what an acceptable versus an unacceptable risk is. And this is important, obviously, to prioritize any security work that we come up with. So in the next slide, I actually want to show you an example. The artifact that we end up with is our asset library. We created an asset library for our fictional bike shops. So let's say one of our asset is the user's emails. The confidentiality bit, the element of the CIA triad, what we want to address here is, for example, we don't want to expose our user's email. And the disaster scenario would be that we would have actually possible legal issues as well as loss of trust. We highlighted this in orange because we want to rate it as a medium impact. Now let's compare it to our second asset, which would be the user's shipping address. In terms of confidentiality, if actually these addresses get exposed, the impact would be really high. So the legal issues would be a lot more likely, and we would also have loss of trust. Now let's look at an asset, the bike prices, for example. In terms of confidentiality, if they are exposed, they would actually not have a high impact at all because they're already public. But if you look into the integrity, if a malicious user actually tampers with our bike prices in our billing system, that would have drastic issues. So this is a high impact also because it would lead to incorrect billing, potentially also loss of revenue and loss of trust. So I hope this example clarifies the terms assets and security goals. And now I'll hand over to Michael to talk about how to do Agile Threat Modeling. I think you muted, Michael.
Thank you, I have to unmute. So now let's talk about the actual agenda for an Agile Threat Modeling session. So please keep in mind, we want to do Agile Threat Modeling in small increments, and we want to do it often. So we should time box such a session to 1 hour to maximum 90 minutes. To be able to talk about the right pieces of, let's say, security concerns in our system within this short period of time, it is very important that you set a realistic scope. So therefore, you should define a narrow, realistic scope for a 1 hour session. Because, as I said, we want to threat model little and often. And be careful not to get trapped in rabbit holes. So moderating such a session, it is very important that you realize when people get stuck in too detailed technical discussion and help them to move on to other topics, because we want to collect as much as possible, prioritize, and then talk about the right things. The second step in our session will be drawing an architecture diagram. And make sure to draw this diagram together with the whole group during the threat modeling session, because you want to use this exercise to gain a shared common understanding of the system you are building. It's very important that everyone in the session is aware of what you are doing and you have a common understanding here. So really use the chance to draw this together. And then comes the fun part. We call this evil brainstorming. It's investigating our model, our architecture, and finding as many security flaws or security risks as possible. We will introduce a framework for that, or a little mental model for that called STRIDE, that helps us to look at our architecture or our system from different perspectives. And the last part of the session is then to prioritize your findings. And prioritization helps you not to waste time on the wrong things. So prioritization helps us to actually focus on the most valuable pieces of security work from a risk perspective. And finally, you can add work to your sprint backlog, or we will soon see that there are different possibilities how you can document the findings and introduce them in your delivery workflow. Last but not least, you should retrospect your threat modeling regularly and improve your skills there. Before we start our session, I think it is very important to talk about different mitigation strategies, because teams often tend to only think about mitigation measures, which means putting additional work in security measures and adding additional components into the system. So yeah, creating additional work. But there are also other strategies that are worth mentioning. So one important strategy, or one strategy you can try to use, is you can transfer risk. So for example, instead of implementing something on your own, you can maybe buy an existing cloud service or something that does the trick for you. Or you maybe have another team in your company that handles certain fields of security, and you can just hand over the things to them, like hardening your database or better configuring web servers or stuff like that, which is often a field for experts. Another approach is to totally avoid a risk. So if you discover a big risk of data exposure, for example, for a feature in your system that is of low value, you might want to decide to skip this feature completely, because it would be too much effort to make it secure compared to the value that you expect from such a feature. Accepting a risk can also be a sound approach. But it's very important that you keep track of risks then and keep like a security debt log, because a risk can be acceptable at some stage of your development process, but completely unacceptable once you come closer to production. And you want to be aware of that and have it documented so that you can come back to it at the right time. So now is another round of questions, if there are any.
There are a few now.
Okay.
Some were already answered, like somebody answered them, but I would still raise the question, if that's okay. The first one that was asked was, would you still have a security expert as part of the dev team? as QA, DevOps, infrastructure?
That, in my opinion, tends to depend on the project. I don't, from the approach that we're advocating for, it is not strictly necessary. I think Mario also answered this in chat already. What is useful, but what you usually have is having people who are interested in security and have opinions on security, and then have a culture in your team where learning new things is actively encouraged, and that will make everyone safer.
Yeah, it was a similar answer given by Mario.
Yeah. Maybe I can add something that I would say we have kind of a networking approach here. So we have people in the team that take the head of a security champion. They don't have to be a security expert, and they then organize themselves on another level. So for example, meet weekly and discuss findings or incidents. And in such meetings, there can be security experts involved, or people who have much more knowledge about security, or try to aggregate this on a company level to have a good exchange and a flow of information from the teams to the experts and the other way around.
Yeah, thank you. Okay. Somebody recommended or asked if anyone has read the IT Grundschutz Compendium of 2020 and also posted a link. So maybe you want to check that out, because there is the explanation for integrating security into programming projects. So I think it was more recommendation than a real question. First question, it's sad for Katharina, but maybe someone else can answer it as well. How do you advocate for security as a continuum and not a binary thing? AKA, there is no fully secure or insecure, but grades and risks and so on.
Yeah, I can take the question. Thank you for this excellent question. That is usually indeed a challenge that we face partially because of traditions in software development that come from waterfall, where everything was hammered down as much as possible before anything was released. The other thing, I think, in my personal opinion, because people just like disasters and they like to see things wrong. But for the purpose of actually having the conversation, I usually have two approaches. If there is a really a lack of understanding of the concept that 100% security is impossible, there are good examples out there of industries that have had to solve this problem before. For example, aeronautics or nuclear power, where not having 100% security is more of a problem than in most software projects we come across, right? There are obviously domains when this is not true. If we look at the automotive domain, there are subsections of that where lives are at stake. If we look at medical devices, that is also true. So, and obviously the above mentioned domains like power and aeronautics also use software. But all of these industries have clear understandings that what you cannot do is create a world without risk, without actually escaping the physical universe. And there are procedures in place, and actually good procedures that we as a software development world have already learned from, like having postmortems and stuff like that, having a process of learning from what has happened that can be a good illustration for people who approach this topic for the first time. And that is usually easily understood. Like everyone has flown with a plane and everyone knows plane crashes, and everyone knows that having a plane crash is not the ideal state of flying. And I think mostly agrees that the people working on planes try to not make that happen. And like this that can be a good in on having a conversation that 100% security isn't possible, that we have to make decisions based on as we've already heard, the assets that we're trying to protect. What is the business value? And attached to that, what is the risk if the security goal is broken? Now, that is one thing. The other thing is, again, like really talking about money in a way. So what does it cost me to make a small contribution to security, and what does it cost me to try to reach my 100%, right? We see the same argument in resilience engineering. People put out SLIs of 5 sigmas without usually understanding what it means in terms of engineering costs to actually make that happen. So having a conversation of this is what it will cost you to do the security improvement for this return is, in my opinion, a good way of engaging with people who are more removed from the technical side. Yeah, let me just stop there. I can go on about this.
Thanks a lot. I think a little bit linked to it is the next question. Is there not the threat that because security is just reviewed on small code pieces, the interaction of all code in production has a risk? And half a bottle of wine is not dangerous, a man is not dangerous, a car is not dangerous. What about a drunken man in a car?
Maybe I can start on this one. What I see, what we are doing on our account is that we have different groups who look at our product from different perspectives. So we have the small, let's call them service teams that maybe develop 1 or 2 microservices. And we have cross-functional concerns discussed in so-called guilds, where we, for example, look at infrastructure topics, look at security topics, look at front-end topics. And in the guilds, I would say, the focus is much more on the overall system than on an individual component. So a guild should be aware of how things work together from their perspective. And I would say this would be a good place to do a threat modeling on a system level rather than a component level. And I would expect many of those problems to be investigated or to be raised in such a group of people.
Totally agreed. There's one thing I would want to add with that. Even when we just have a look at components and we look at the threats that can happen to our components or on a fairly small scale and apply, and we'll come to that in a practical example, apply a subset of common problems or try to solve a subset of common problems, we can actually usually already secure a significant portion of the software. Now, that obviously isn't always true, and especially so that tends to be more true in the pure software world. This gets a little bit more hazy in the infrastructure world, because infrastructure is also something that is usually seen as something that just happens on the side. As security and security concerns work very much with patterns, where we can more easily say there's possibly a problem with authentication, there's possibly a problem with the service not being available, there's possibly a problem with our data integrity being violated. This actually propagates relatively well in systems. But as Michael has already said, nothing in this approach needs to stop us from looking at the system as a whole. Just in the way that we work in a daily manner, we can do this while writing software in an iterative manner and also think about security.
Thanks a lot. Do you want to take one last question? Or do you want to move on?
I would suggest that we take more questions towards the end of the meetup so that people who are still interested in it can stay and the other have a chance to attend the threat modeling session now.
Thanks a lot, Michael. Cool.
Okay, then I would hand over to Katharina, and we would directly dive into, let's say, real threat modeling session.
All right. So I hope my screen sharing was successful and you're now seeing a mural board.
Yes.
Excellent. All right. Welcome to our practical part of this meetup. Again, apologies that we didn't find a good way to make this actually interactive. If you have feedback or suggestions for that, we're absolutely happy to hear them. What you're seeing here is a mural. It's a collaboration tool that we use to do Agile threat modeling while we work remotely. The template that we see here from Mural was created by colleagues at Thoughtworks. We're really grateful for that. And what I want to say is that you don't need this tool to do Agile threat modeling. We have done Agile threat modeling using Confluence, which is obviously less responsive. We've used it while taking pictures of stickies and posting them in Slack. So you can get creative to do this in a remote setup. Having a tool like that helps because this tool helps us to do three main things. First of all, as you can see kind of on the right-hand side here, it is itself a framework that kind of helps us frame our thoughts while we progress through the session. We will be able to do voting in that, and it also helps us to keep time. So there's a way that we can actually just, as you would maybe know it from retro, have a put a time limit and have an automatic timer for issues that we're discussing. But as long as you keep this in mind, you don't actually need this tool to do threat modeling. And now let's actually start. So we start with the technical diagram. Now, for the purpose of this meetup and in the view of the time, we've cheated and already drawn the diagram, but I really want to reiterate what has already been said. Please take the time to actually create this view of the component and or system and or story that you're threat modeling together as a team. Because what this gives you is really a shared understanding of what you're talking about, which is not necessarily trivial to achieve. And what it also gives you, ideally, is a safe space to discuss your thoughts on the system. And you want to create this safe space, not because it's a nice and fuzzy word, but if you have a space where everyone can ask questions that they have about the system, you will actually get the insights from everyone in your team. And I'm sure I don't have to say that, but really independent of grade and knowledge, if people ask the questions that come to their minds, you will gain insight. They will trigger thoughts in your own brain, in someone else's brain. So create a safe space. It is a worthwhile thing to do threat modeling. But now I actually hand over to Michael and Jennifer, who will talk about the system that we're going to threat model today.
Sure. So let me describe the technical diagram. If you look at the components, so we're opening up a fruit shop web shop. And if you look at the components, we have a front end, which is connected to a back end, which is connected to the database. And then also to handle payments, our front end is also connected to a payment service. Now, an important thing to look at in the diagram is also any kind of user interaction and also the data flow. So the user enters the website, and then the data flows through the backend and is stored in a database. And then also the data flows to the payment service where we handle any kind of payment. For the sake of our exercise, this is our scope. And I think we mentioned already before, the scope can be bigger. You can also really focus on a small scope. For example, you could just focus on the connection between the backend and the database. Do you want to add anything, Michael?
No, you explained it very well. I think one thing that's missing is the boundaries that we depicted with these orange lines. So if you have authorization boundaries or clear system boundaries, it also helps to draw them in the diagram.
Cool. So the next thing we talked about is we want to actually see what we're trying to protect, right? We want to understand, do we have assets in this? And if so, what are the assets? So Michael, Jennifer, is there something in the system that we want to protect?
I would suggest handling payments can be really critical. So I'm gonna, let me draw some assets here with the payment service. I think this is definitely something we would like to protect in our system.
Yeah, and when I see front-end users in a backend database, I suppose there are some kind of user accounts stored in the database. And as we all know, address records, email addresses, probably passwords in the worst case, are something that attackers often hack systems for. So I think that is also an asset we want to protect.
So there might even be GDPR relevant information in this database.
Yes.
Nice. Sure, that's going to be interesting. All right. So we as you can see, we're like play acting this, so bear with us, right? We understand that this is a fairly generic example, but let's have a look at what can actually happen to our assets, or if something can happen to our assets. And for that, we introduce another framework, essentially, which is called Stride. There are lots of different frameworks out there that help you guide your thinking about threats in a threat modeling session. We picked Strides because it works for us. It was originally developed at Microsoft, and as you can see, Stride is an acronym, or is a word that is constructed from the first letters of the 6 threats, or the 6 threat domains that it looks at. That is spoofed identity, tampering with input, repudiation of action, information disclosure, denial of service, and elevation of privilege. Before we dive into this, I want to say that the violation of, or the threats coming from this can be malicious and can just be accidental as well. It's always interesting to consider that stuff goes wrong, and this will still have impact on your product or on the software that you're providing or developing. Now, let's have a first look at spoofed identity and see if our juice shop needs to handle this, or needs to handle this threat. So spoofed identity deals with the concepts of identity and authentication, as you probably have already deduced. So this guides our thinking about, do we have any form of authentication between our components? Is it good authentication? Do we need to find out if the authentication is good? Do we actually handle how identity is passed through the system in a good way? Or do we need to think about that? So all of these things are questions that we can ask, that the identity card wants to make us ask. And let's have a look at the technical diagram to see if there are any identity threats in this.
I think the first thing that comes into my mind is potentially if the user, if you don't enforce strong passwords, then someone could just guess the user's password. So I think this is a sticky that will put up in there with the user.
Yeah, and when we see backend services and databases, we probably immediately think about how does the backend service actually authenticate at the database, and most often there are passwords in play. So a question we might ask ourselves is, do we regularly rotate database passwords, or is a leaked database password that allows an attacker to read our database in a longer period of time?
So we have identified 2 threats, and we will come to why only 2 in a second, other than time. Let's have a look at the next card, tampering with input. So this raises one of the key concepts that was already mentioned in the CIA triad, if you remember, integrity. So this is about data integrity. And in practice, we want to ask ourselves questions. Is there a way that the data we're handling can be modified, either accidentally or maliciously, in a way that it shouldn't be? So that can be code injection at different points, but this can also just be accidentally writing the wrong config file somewhere, or overriding or invalidating a config file. So this can go in a lot of ways, as all of these cards. Let's have a look if we find any possibility to tamper with the input in the system.
I think maybe whenever I see a database, I wonder, maybe do we prevent SQL injection? So that could be a way a malicious user tampers with our data, with our system. Where does it fit? Does it fit to the database? Or maybe I'll put it in here.
Yeah, and I think also validation of input that should happen in the front end and also in the back end is very important to mention here, because what happens if a malicious user buys or simulates to buy all our shoes at once and brings our shop out of business? So do we actually validate the amount of shoes ordered, or can someone bring down the calculated stock and thereby bring down our shop easily?
Cool. 2 more threats. Let's have a look at repudiation of action.
Yes, so the key concepts that we want to think about here is monitoring, logging, signing. Basically, what we're asking ourselves is how hard is it for users to deny performing an action? For example, if a user has deleted some inputs in a database, some sensitive information, first of all, do we actually know this is happening? And second of all, can we trace it back to whoever removed this sensitive information? I think with this in mind, maybe we can go back to a technical diagram and investigate.
Yeah, let the investigation start.
Yeah, looking at the payment service, we definitely want to monitor access to it and figure out who accessed it in which way at what time, so that even if a malicious attacker tries to remove his traces afterwards, we have some evidence or information that can bring us to the source of the problem.
That's a really good point. I think my idea was also to log database access. So do we know who's accessing sensitive data in a database?
All right, next card.
So, no.
I think the next one we want to talk about is information disclosure. Again, our concepts that we're talking about is confidentiality, encryption, data leakage, and kind of man-in-the-middle attacks. The question that we're asking is, can someone view information they are not supposed to have access to? An example I can give, can a user read a file they're not supposed to have access to? So let's go back to our technical diagram and see if we have any examples for information disclosure.
And the question was already asked in chat whether the data in transfer is encrypted and the data at rest.
Nice one.
That fits here very well.
Let's add this. So encryption of data in transfer. Thank you.
That's a really good one. I would also maybe say leaking sensitive information in the logs. So I'll put up a ticket for that. Yes.
All right. We have thought about our information disclosure. Let's have a look at the denial of service.
Yeah, so coming back to the CIA triad, denial of service is part of the availability threats. So key concepts are availability, distributed denial of service attacks, botnets, or flaws in content delivery networks. And the question we ask ourselves is, can someone break a system so that a valid user is unable to use it? Often those attacks happen by flooding a system with requests and thereby bringing it down or bringing it to its capacity boundaries. But it's also important to mention that this can easily happen unintentionally, for example, with some component being misconfigured or wrongly configured. So now let's go back to our technical diagram and see whether we can find threats in this category.
I think you named a good example. So maybe like a denial of service attack on one of our backend services.
And since the payment service is very crucial for our shop to generate money, we might also investigate whether the payment service we choose meets our traffic demands even on Black Friday or short before Christmas, right?
Or for Tuesday.
Tuesday.
For Tuesday. Yeah.
Don't forget Tuesday.
Sorry, I forgot about Tuesday. How could I?
All right. Let's go to the next one, elevation of privilege.
The next one is, I think, also the last one. I don't know whether you mentioned it explicitly, but I hope you realize that the first letter of each of those attacks gives the word stride. So that's why this framework is called stride. I think we didn't mention that, but yeah. So the last card in the stride framework is elevation of privilege. So key concepts here is authorization, blast radius, isolation, and possibility for remote code execution. And the question we ask ourselves is, can an unprivileged user gain more access to the system than they should have? And elevation of privilege attacks are possible because authorization boundaries are missing or inadequate. So maybe coming back to our choose shop, we find some attacks of these categories.
I have an idea. For example, with our backend systems also, what if we have vulnerabilities in the third-party libraries that we're using? Someone could actually exploit them to gain more privilege than they should have. Maybe I'll put this with our backend services.
Yeah, and talking about the database, we often see database access being made with users that have too broad privileges. So often developers do not differentiate between a database user that maybe only needs read-only access and use the same user that creates schema updates during deployment or runs maintenance tasks in the database. So it's important to have to narrow down the access to the database and have individual users for individual use cases.
Yep. So before we move on, I want to take a step back and have a look at what we have in front of us now, because I'm sure, even though we know that this is just pretend threat modeling, there are a couple of obvious challenges in the view that we have. First of all, this is a complete flow, right? And we only put up stickies for 2 threats per card. This is a way you can scope Agile threat modeling, but I think what we can see very easily here is that if we had only looked at one of our security boundaries, we would probably have been able to fit in a lot more threats or stickies. And I'm not saying that this is limited because we don't have enough space. This is also about being overwhelmed with the things that need to be done. And this is a feeling that can happen relatively quickly. Even, and again, I want to reiterate, if you have a team that isn't necessarily super knowledgeable about security per se, the devs on your team will absolutely have questions about how do we protect this? Is this a good idea? I've thought about this and that. So they are experts in the software that they're delivering, and they have a good insight. You will come up with a lot of things. So keeping scope, if you're actually facilitating an Agile threat modeling session yourself, keeping scope is one of the key things that you want to keep an eye on, not only in terms of timing, but also in terms of what are we actually looking at. And again, coming back to what I said before, that I believe that people are really attracted to disasters. One of the things that we see relatively regularly is the arcane in security, right? Like the state level actor that will do the most amazing thing, or the news bulletin of the vulnerability that was finally made public this morning. But keep in mind, what you're trying to do is you are trying to implement a decent amount of security based on the thing that you're trying to protect, that you have assigned value to. And as we will come to in a minute, based on the likelihood of whether this is actually going to happen or not. So keeping scope is important. You can zoom out. You will need to manage the threat modeling session in a different way. All right, then that's actually—
Can I add one
Yep.
thing? Because we talked a lot about getting the whole team involved. And when I actually conducted my first threat modeling session, I was really surprised and impressed by what happens if you tell a room of 10 people to take 5 minutes in a bunch of stickies, and each person individually should write down some threats on a sticky and then collect them in the group. So you will be surprised how much knowledge you have in the team and how much different perspectives you get by that, by simply letting people brainstorm for 5 minutes about your system, individually or in small groups or however. It's really amazing, and it's one of those small things in this approach that I really like.
Thank you for saying that. That actually also reminded me of one more thing that I wanted to say about this diagram, and actually a question that was raised earlier in chat, and that is like, if I only look at the different components, will I make my, will I still have an overview of whether my system as a whole is secure? If we look at certain patterns, for example, if we look at encryption and authentication, they're usually very good patterns for exactly that. Availability tends to be harder, but encryption and authentication tend to be more easily understood in that context. If I just have a look at this traffic flow across this boundary and make sure in the story where I am implementing this, I have an idea of how I will get my traffic encrypted. And I do the same in this story. And I have an idea on how I want to handle just the HTTPS requests in the beginning and certificate management or what have you. Then suddenly I have an encrypted traffic flow, which takes care of a significant amount of problems, independently of what my threat actor is and what their entry point is. So even if some of the examples may seem very generic and the stride cards may seem very zoomed out, they will help your thinking of, again, implementing a decent state of security. And if you look at your own software projects, I'm sure that each and every one of us knows about even those very generic things not necessarily being applicable to what we're working on at the moment. Let's actually get to creating some work from that, though. So let's, the next step that we're going to do is we're going to have a look at all the threats that we generated, and we're going to vote on them. Now, we're not going to have the complete discussion here, but while Michael and Jennifer are rearranging the stickies, this is the right time to discuss is how likely is this risk? And here we don't actually only have, is this publicly available? So what is the scope of our threat actors? How much knowledge do they need to know? Is this very common, which is usually a good indication, as we've seen at the very beginning from records lost in security incidents in big companies. So all the cues that we can ask here about how likely is this risk. Another thing that we see is there a governance policy that actually requires us to deal with that? And again, there are domains when this will absolutely be the case. But again, I encourage you to see this as a benefit because you're already paying forward to this compliance, right? You are already building in good practices into your software because again, essentially, we're all trying to solve the same problem. So for the sake of this threat modeling, we won't actually discuss it for all of those threats. We're just going to go ahead and vote. Let me start the voting session.
So while we are voting, maybe one thing that should be mentioned again, it's very important that you prioritize the findings before you start talking about mitigation, because otherwise you easily run into the issue of not talking about the things that have the highest value. So this is, I think, a very important concept for all kinds of iterative or working in small batches, that whenever you start work, you think about what has the highest value. And again, here in this threat modeling session, before you spend too much time talking about non-valuable things, vote and find highest value.
Yeah, excellent. Yeah, absolutely. All right, shall we vote?
Woo!
Nice. I hope I didn't end the session too early, but yeah, we have 2 stickies that received 3 votes. So let's move forward with the 2 of them. And so we actually move to the next and last section of our threat modeling session, and we think about mitigation. And one of the things that Michael has already said is we, especially as engineers, we tend to think about mitigation as we need to fix this. But this is actually just a relatively small scope of what we can do when we have identified a threat. Sometimes even if we want to do something quote unquote technical about it, that can just be keeping an eye on things, right? Like putting logging and alerting in place can be a good way to approach a threat, because that can help you define a path to react if something happens. We can also transfer, just to reiterate, then we can ask, who do we transfer this risk to? We can avoid it, and it's really useful to ask, do we actually need to implement this? And once work has been generated, I know that people usually hesitate in refinement or planning sessions to ask the question, is that something that we really want to do? But after you've done threat modeling on something, if you find out this looks like a spectacularly bad idea, you may just want to, respond in an agile manner and say, I think we have to think about it again, and maybe not do it. And then you can accept risk, as Michael has already said. And there it is important that it is clear who owns that risk. And not only in terms of who's responsible for it, but as Michael has already also said, who keeps an eye on how long we can accept this risk. All right, let's have a look at our 2 threats and what we want to do about them.
So fail to meet traffic demand. Is that something that we should actually mitigate as part of a story in the next sprint?
Do we know how to do this or should we maybe find out how we can handle that? Because Tuesday is coming up, and I think we all of us agree that we want to handle this.
Mm-hmm. Yeah.
I would definitely investigate into having more than one payment provider in the backend, so we can maybe round robin our requests or fall back to a different provider if one is down, as we saw last week.
So, oops. We think we'll mitigate this, and we'll spike, maybe in the next sprint we can spike, if I can type, some sort of auto scaling or something like that.
Auto scaling or redundancies in the external providers we use. Yeah.
All right, so we're gonna mitigate this because Tuesday is coming up, and I can't copy paste this sticky. Nope, not doing it. Let me. Can someone else copy paste this?
Sure.
I can give it a try. Oops.
And I think for the encryption at rest, I heard that we can just talk to the infrastructure team to give us an encrypted database. Maybe that's something we can do.
Which would fall under transfer, right?
Yeah,
That's actually a good idea.
right. And I think my external keyboard has just given up.
I can give it a try when you leave the card.
Failure pattern for Agile Threat Modeling. Your keyboard dies. To be totally honest, I like accidentally spilled maybe half a glass of wine across this yesterday, so I guess it's my fault.
Okay, are there any other actions we want to take on those two findings?
I think let's go with this. We'll revisit it anyway. We'll have a couple of more cards in play, and we'll stay on this component for a while yet. So I think we'll have another threat modeling session next iteration, and can have a look if from the things that we've learned in the next 2 weeks, we'll change our mind. All right, so this was our threat modeling session, or the play acting threat modeling session. There's a couple of things I still want to say before we go to the end, or to the wrap up. And this is something that you practice, right? Doing threat modeling, you practice with your team. It is something that you get better at. This way of thinking in scope. So be patient with yourself, be patient with your team if you want to try this out. This is also why we started at the component level. This is something that you will get better at this the more you do it, as with all things that you learn. And actually, one of the things that I forgot to mention when we were talking about the voting, and I can't leave that out because one of my colleagues mentioned this quote to us while we were preparing this meetup. So I just want to repeat it. It's a quote from the Canadian astronaut, Chris Hadfield. And if I had stuck with the plan, I would have said it here. And that is, there are a million things that can kill you. Focus on the next one. So this is how astronauts approach risk. And now let me stop sharing and let's wrap this up.
Do I have to share again? Oh, I will.
I think so.
Yes.
Give me a second. Okay, so we continue. Can you see my screen?
Yeah.
Yes.
Okay, so we continue with another round of questions. Shanna.
Okay, there are quite a few. I will try to go to the ones first that haven't been answered in some way in the chat yet, and then we'll go back to the one that maybe has already been answered. Somebody asked, we go for, are you also differentiate different or multiple actors with different rights and permissions, or are you just take a look at one actor per time, in this case, user?
Yeah, as you have seen in the section where we assess the likelihood of a threat, that is absolutely a relevant question to ask. Is this an external or an internal actor? Again, for certain risks, this will not actually make much of a difference in my experience when it comes to mitigation. For example, if you think about encrypting your traffic at rest, you have covered quite a broad subset of people who can interact with it. Now, if you go further and think of who has access to the keys, that is not true anymore, right? Because then you're like very, very obviously focused on internal threat category. Anyway, word is missing. But a lot of the, again, decent security measures don't necessarily need you to consider the level of knowledge or the level of access of a threat actor. That's also why I really mentioned that a lot of things can just go wrong accidentally that fall into the area of security, and applying decent security can help you with a lot of things. Again, this is not about making things perfect, and it never stops you from coming back and taking another look.
Somebody also asked, what about the user itself? It was at 7:30, so I don't really know what it was directly referring to.
I think it was about the assets. So the question was asked when we were trying to collect the valuable goods in our system, or the assets. So I think the user leaves traces or data in our system that we, of course, treat as assets, but I would say we cannot treat the user itself as an asset. The only thing I could think of is that we, of course, try to protect the user and his machine from being attacked by someone else by using our system. That could be the only maybe kind of weird scenario where I think that we would think of the user itself as an asset. Maybe Katharina and Jennifer, you have more creative thoughts on that.
I mean, one way in which you use as an asset is trust, right? Like, do I use Face as a company if user data is lost, if my system doesn't work? Do they go somewhere else if my payment service isn't available? So if that was the thought behind the question, and I hope this is answered, and otherwise I would ask the person to just ask it again.
You can also unmute yourself if it's needed, of course. Okay, I would move on to the next question, but please just ping it to the chat if you still want to mention something. You mentioned third-party libraries with vulnerabilities as a threat. Would that be more like a bug and not a design flaw, which we are actually looking for in a threat modeling session? But of course, it is necessary to see not knowing about third-party dependencies with vulnerabilities as a security risks, which can and should be reduced. It's quite a long question. So that was asked by Melvin, if you want to check out the chat.
Yeah, maybe I can take this one because I think I wrote the sticky. I think, Melvin, you're absolutely right. So what I was going for was the threat is we don't know that there's a vulnerability in our dependencies. And this was under the category of escalation of privileges. So an attacker could actually use that vulnerability to gain access to our system.
Yeah, there's it's a really good question in several regards. I want to mention as well that one of the lively discussion I've actually been in recently in Thoughtworks is whether it is permissive to treat security risk or risk in general as tech debt. And I can see there's a lot of academic, I think academic reasons not to do it, and I understand them, but I'm really passionate about being like, giving teams a way to tackle things. And in my experience, teams usually tend to have a way of tackling tech debt. There usually is a process in place. There's usually a way to write it down somewhere. There not as often, but at least exists a feedback mechanism. How often how often will I pay back tech debt? So just from a practical perspective, in terms of the threats that I discover, will I pay them back? I think this can be considered tech debt, or I think it's useful to group this. Now, you're right, of course, that this is not a threat, or this is a bug from the people who wrote this software that we're using, but we can't actually do anything about it. And one more thing about dependencies, which we're going to actually come back to in a different session, is there are obviously relatively good tools to scan for vulnerabilities in different places in our path to production. What is usually missing in my experience, again, is the feedback loop, right? Like now I have something in my pipeline that scans my Docker images, and it generates a bunch of data with a lot of findings. What now, right? And then again, you're in this kind of procedural problem where how do I handle the things that I find? And that is something where we hope to give an insight in through acceptance, mitigation, transfer, and also just writing things down, putting things as part of stories or in some kind of decision document in our whatever Confluence or other document store. There is a way that things will not be forgotten, and the team won't get frustrated and discouraged by the feeling of issues that they've correctly identified not being addressed.
Thank you. Okay, now to the question that has partly been answered. In a large product development, how would you synchronize security threats with a blast radius across multiple teams? For example, impact of changes in IAM, I assume it's identity and access management roles in clouds.
Yeah, very good question. Michael, you want to talk?
I think it goes in the same direction as this threat that becomes real if the drunken man sits in the car. On our account, this would be something that I guess the infrastructure guild would be tackling, because it's a concrete example of cloud infrastructure, or I assume you're talking about cloud infrastructure. So I would hope that with the right people in such a group who have the overarching overview of the components and services being built and also about the underlying infrastructure, such threats or potential threats would be discovered or in this group.
Yeah, I would agree. I would want to add what this usually boils down to is trying to understand the trade-off between individual teams being able to move fast while also protecting the rest of the organization, right? And then it obviously depends on how segregated is your infrastructure set up overall, how much of the infrastructure is owned by the team, are there external parties that have an interest in this, and if so, how is this applied? And if we assume that there are guidelines about how, for example, IAM roles or minimum requirements for IAM policies, for example, one of the things that you could imagine is, or one of the things that you could look at is, what is my environment segregation? And do I, for example, differentiate between having some kind of sandbox account where my team can just really think about, go ahead and throw ideas at the wall, and then get more restrictive as I go to production, with production applying the policies that were, again, ideally agreed in some kind of guild scenario. And that gives you a good trade-off when we think about teams being able to experiment and move fast while applying the baseline of policy constraints across the organization. But yeah, not a straightforward thing, for sure.
Thanks a lot. Oh, there is even one last question if you still want to take one. Does it make sense to analyze all components of a platform in one diagram, or does it recommend to look at each application separately? What is your best practice in this regard?
I think when I imagine all the components of our current project being put in one diagram, I think it's really hard for people to see anything useful in that. So maybe it helps to bring things in the right level of abstraction. And when you talk about the whole system, you might use system boundaries instead of individual components, and go into the individual components in a smaller scope. But I'm not sure whether that really answers the question.
You gotta thank you, so I assume.
Yeah, I mean, I would recommend use different level of abstractions and try whether that helps. And yeah, split things up as much as possible.
Yeah, thanks a lot. Okay, that was the last question. I hope I haven't skipped one. If there is any question I skipped, please make me aware. Other than that, I really enjoyed the meetup, and I think I was not the only one. So thanks a lot.
Sorry, can we?
Yeah.
I know that we're over time, but we have a couple more slides.
Go on, Katarina. All good.
We'll just quickly wrap up. So we're almost at the end of our meetup. We just want to quickly summarize what we've discussed. So Agile Threat Modeling is a journey, and the beginning of the journey is where we define our assets and our security objectives to be able to prioritize the threats. And then I think what's been mentioned also often in the questions, we threat model often. That could be per story or exploratory in a more abstract context. And during our Agile Threat Modeling workshop, we ask 3 questions. What are we building? That's a technical diagram. What can go wrong? That's the evil brainstorming. And what are we going to do about it? That is when we actually mitigate the threats. And if you do threat modeling often, you will eventually create a community around security and increase awareness in your team. And that is exactly where you want to be. So if you look at it from like a different angle, threat modeling is only the beginning, and we know security is a lot more. So Agile Threat Modeling focuses on the design part of our journey. We're now at the end of our meetup. If you go to the next slide, we have a lot of resources that we're going to share with you. We'll send it in a follow-up email. But thank you so much for your attention and your time. And we're definitely going to stick around for a while if there's any more questions that you want to ask us.
Yeah, really, really thank you for making the time. I particularly want to shout out a couple of names before we end. And I want to thank Katja Benzig and Steve Upton, 2 of our Thoughtworks colleagues who made the time to actually do the dry run with us and give feedback on the presentation. And then obviously we really want to thank Jenna and Katarina for helping out to make this possible from a technical level. Thank you.
Thanks so much. And yeah, once again, we'll share recording and slides as long as you RSVP'd with yes to the meetup, because we don't want to bother all the other meetup members. Okay. Thanks so much for attending. I will save the chat because I think there was quite a lot of action ongoing and some feedback for you. So.
Cool.
Okay. Thanks so much.
I think we'll keep it open for another 5 minutes to see if there's more coming in.
Perfect.